Hi, I'm Patrick Reagan. Welcome to TCP/IP Part 6 IP version 4 addressing. This is the first of the TCP/IP series where we discuss IP addresses and subnetting. This video will start by first looking at the IP version 4 configuration and then breaking down the IP4 address, including the subnet mask, default gateway, and DNS server. We then cover classful addressing, classless addressing, and private addresses. As a reminder, since we're starting to dig deeper into the IP addresses and subnet mask and show the binary equivalent, if you're not familiar how to convert from binary to decimal numbers and back, you should watch the first video of this series, TCP/IP Part 0, Decimal, Binary, and Hexadecimal Conversion. By the way, this is a great video to pause the video as needed to study the diagrams, let it soak in, and do any binary calculations that you may need. Each connection on a TCP/IP address or logical address is called a host. A host is a computer or device with a network interface that is running TCP/IP and that is configured a unique logical address such as 192.168.5.243 or 50.233.23.17 that acts as a digital home address. It is called a logical address because the IP address is assigned to a device on a network, but is not tied to the physical address like a MAC address, and it can be changed or reassigned by software or network configuration. You'll then need to include addresses for computers, servers, remote access management ports for servers, network printers, connections for routers, and management ports for routers and switches. When planning a TCP/IP network, make sure that you think of potential growth where additional hosts may be added to the network in the future. For a host to communicate on a network, it typically needs an IP address with a unique logical address assigned to the host, a subnet mask which specifies which bits of the IP address is network bits and which bits are host bits, a default gateway, which is the IP address of the nearest router which allows communication with other networks, and a DNS server which provides name resolution to IP addresses. This screen shows the same information but using the ipconfig command. The IP version 4 address space consists of 32-bit addresses notated as 4 8-bit decimal values from 0 to 255, separated by periods, as in example 192.168.43.100, 131.107.3.1, and 2.0.0.1. This is known as the dotted decimal notation, and the individual 8-bit decimal values are called octets or bytes. Remember, when you have 8 bits, there are 2 to the 8th power equals 256 combinations, which is represented by an octet. Since the address is used to identify the computer, no two connections can use the same IP address on the same network. If there is, one or both of the computers will not be able to communicate. Here is a breakdown of classful addresses. The primary classes are class A, B, and C. If the IP version 4 address starts between 1 and 126, it is a class A with the default subnet mask of 255.0.0.0. A class B starts with 128 to 191, which has the default subnet mask of 255.255.0.0. And a class C starts between 192 and 223 with the default subnet mask of 255.255.255.0. Remember, the default subnet mask tells you which bits are the network bits and which bits are the host bits. For example, the 15.54.23.5 address, the network part of the address is 15, and the host part of the address within the network is 54.23.5. For all hosts within the network, it has to begin with 15. As you can see with the 143.56.187.54 address, the network part of the address is 143.56, while the host part of the address is 187.54. For all hosts within the network, must begin with 143.56. course, Class C has the first 3 octets locked in for the network portion. Therefore, in the Class C example with the subnet mask of 255.255.255, the network part is 192.168.43. There are 2 additional classes in the classful addressing. Class D is used for multicasting, and it begins between 224 and 239. Multicasting allows sending from one to many with one set of packets. Class E starts between 240 and 254 for experimental or future use. Today, Class A, B, and C are mostly used for subnetting, while Class D and E are not. A subnet mask is another 32-bit value consisting of binary 1 bits and 0 bits. Subnet masks specify which bits are network bits and which bits are host bits. When compared to an IP address, the bits corresponding to the ones in the mask are the network bits, and the bits corresponding to the zeros are the host bits. Subnet mask can be shown as CIDR, which specifies the number of network bits. For example, 255.255.255.0 is expressed as /24 because their 24 bits are network bits. All computers on the subnet should have the same subnet mask. Remember, for a subnet mask, you should have all ones on the left side and all zeros on the right side. If you look at the 192.168.43.100 address with the subnet mask of 255.255.255.0 or /24 CIDR notation, you can see the subnet mask, when converted to binary, has 24 ones followed by 8 zeros. The green bits of the address are the network bits, and the purple is the host bits. You can think of host.100 located on the network 192.168.43.0. And here's another example we looked at earlier with the Class A network, with the green showing the network portion of the address, and the purple is the host address within the green network. With the classes, many addresses are wasted. For example, how many networks do you know have more than 16 million addresses as assigned to a Class A network, or even 64,000 for a Class B? The subnet mask can be changed to take a large network and break it into several smaller networks called subnets. This allows a corporation or organization to be free to assign a distinct subnet number for each of its internal networks. This allows the organization to deploy additional subnets without needing to obtain a new network number from the internet. Remember, the subnet mask is used to define which bits represent the network prefix, including the subnet number, and which bits represent the host address. The network prefix and the subnet number are sometimes referred to as the extended network prefix. For a subnet, the network prefix, subnet number, and the subnet mask must be the same for all computers. Variable length subnet mask, or VLSM, is a computer networking technique that allows network designers to divide an IP network into subnets with different subnet masks. More on that later on a later video. The 127.0.0.1 address is a reserved address called the loopback address, which points to a local host or itself. In fact, the entire 127.0.0.0 network is reserved for loopback addresses. If you ping 127.0.0.1, you're basically pinging yourself, which is used to test if the IP protocol stack is running on your machine. The RFC 1918 defines 3 blocks of addresses allocated for private use, which are 10.0.0.0 with a CIDR notation of /8, 172.16.0.0 with a CIDR notation of /12, and 192.168.0.0 with a CIDR notation of /16. These addresses are not available on the internet. Most enterprise networks use addresses from these blocks for the internal host and network. RFC 1918 private addresses are often used with network address translation, or NAT, that allows internal network devices to communicate with external devices on the internet by translating private IP addresses to a public IP address assigned to the router or firewall. It does not matter if other organizations use the same addresses because the hosts are never directly connected to the same network. You should never see traffic from the internet come from these private addresses, which is ingress or incoming, since the address ranges are not routable on the internet. This potentially gives every corporation or organization up to 48 million addresses to use for the internal network, more than enough addresses to connect all of their sites and subnets. Network Address Translation, or NAT, is a network layer routing technology that enables a group of workstations to share a single registered address. A NAT router is a device with two network interfaces, one connected to a private network and one to the internet. When a workstation on the private network wants to access an internet resource, it sends a request to the NAT router. Normally, a router passes traffic from one network to another without modifying the data. However, in this case, the NAT router substitutes its own registered IP address for the workstation's private address and sends the request onto the internet server. The server responds to the NAT router, thinking that the router generated the original request. The router then performs the same substitution in reverse and forwards the response back to the original unregistered workstation. The router, in essence, functions as the intermediary between the client and the server. A single NAT router can perform the same service for hundreds of private workstations by maintaining a table of the address substitutions it has performed. In addition to conserving the IPv4 address space, NAT also provides a certain amount of protection to the network workstations. Because the workstations are functionally invisible to the internet, attackers cannot readily probe them for open ports and other common exploits. As you can see from this figure, a simple form of network address translation called static NAT, where a single internet address is mapped directly to an external IP address. When the host 192.168.0.101 is accessing the internet, the packets will reach the router. The IP address is removed, replaced with 180.12.18.101. So as far as the internet hosts, the packets are coming from 180.12.18.101. When the internet host responds back, it will send back to 180.12.18.101. When those packets reach the router, the external IP address will be removed and replaced with the internal address and sent back to the client host that did the initial request. Most organizations will use port address translation, which the internal users will share the same external IP address. To keep track of the internal host requests, a port is assigned to differentiate the various client hosts. The NAT mapping table will keep the connection straight so it knows the IP addresses to remove and replace when the packets go through the router. The default gateway specifies the router on the local network. If you need to communicate with other subnets, you need to specify the default gateway. Think of it as a gateway or doorway to get out of your local area network. The default gateway must be an IP address on the local subnet. Any packets that are sent to other subnets, those packets will be sent to the router, which will then figure out the best way to get to the remote subnet. The default gateway should have the same network address and subnet mask that the client has. You'll need to specify one or more DNS servers so that the client can resolve name to IP addresses. You should specify a second DNS server for redundancy in case the first DNS server is not available. For clients, you should avoid static IP configuration. Dynamic Host Configuration Protocol, or DHCP, can automatically perform IP configuration, including IP address, subnet mask, gateway, and DNS server. The DHCP process, DORA, is short for Discover, Offer, Request, and Acknowledgement. Step 1, the client broadcasts to a DHCP server to discover available DHCP server. Step 2, the DHCP server sends some IP address options to the client. Step 3, the client chooses an offer and makes a request to the DHCP server. Step 4, the DHCP server sends an acknowledgement to the client. And the client has its IP configuration, including IP address, subnet mask, default gateway, and DNS servers, which is leased to the client for a specified amount of time as dictated by the DHCP administrator. If you need to make sure the client gets a specific IP address or the same IP address, you can use a reservation that's based on the system's MAC address. If the DHCP server is not on the same subnet as the client making the request, an IP helper or DHCP relay agent will be listening for those broadcasts and will forward them directly to the DHCP server. Remember, broadcasts do not typically go through routers. Automatic Private IP Addressing, or API-PA, is a non-routable linked local address that is assigned when a client cannot find or connect to a DHCP server, and it will assign itself an IP address. API-PA address begins with 169.254 and has a subnet mask of 255.255.0.0. Therefore, if you see a client that has an address that begins with 169.254, make sure the computer is connected to the network, cables or wireless connection, the DHCP server is running that handles the automatic IP configuration of the system, and that the DHCP helper or relay agent can forward the DHCP request to the DHCP server. In Windows, you can see the IP config, which is shown on the left, and the IP config/all is on the right, which also shows if the address was assigned by DHCP, as indicated by the Auto Configuration Enabled option, and the MAC address as indicated by the physical address. If you scroll down further, you can see the DHCP server that configured the IP configuration as indicated by DHCP server. Here's a simple network with a router that has two links, each with its own switch. The clients connect directly to a switch or indirectly to a switch via a wireless access point. This is the same network, but the symbols are removed with more realistic representation of the routers and switches, just so you can visualize it better. So back to the symbols. The router will subdivide the network into two subnets. If you look at subnet 1, you have the subnet mask of 255.255.255.0, which tells you that the 192.168.50 is the network portion of those addresses, which means every host on subnet 1 must begin with 192.168.50 and should have the same subnet mask of 255.255.255.0. Even the router links on the subnet begins with 192.168.50 and has the subnet mask of 255.255.255.0. Similarly, subnet 2 is also uses the 255.255.255.0 subnet mask, which has the network portion of the network of 192.168.45. Take a minute to look at this figure and find the problems with the network based on what we just covered. You can see the two pink systems on the left have the same IP address. Remember, each host has to be a unique address on the subnet. The pink system on the right has the same network address of 192.168.45 and the same subnet mask as the other systems on this subnet, but is pointing to the wrong default gateway. The default gateway has to be the IP address of the router link on the same subnet, which should be 192.168.45.1. Routers need to have IP addresses because they're used to connect networks and forward packets from one network to another network. For a switch to function, it does not need an IP address since all of its decisions are based on MAC addresses. However, the only time a switch would get an IP address is so that you can connect to the switch remotely to manage it. Here is taking a bigger look at our sample network. Now the internal router connects to another router that goes through a firewall and a third router, the ISP router, to get to the internet. Routers again will break up the network and link the subnets together by routing and forwarding the appropriate packets. The ISP router is our external router to get to the internet and will perform the network address translation function. We could even add another subnet off the firewall, which is our DMZ or screen subnet, which represents the organization servers that are accessed from the internet. Question: what are the 4 necessary components that you have to configure for IP version 4 so they can connect to the network and surf the internet? Answer: IP address, subnet mask, default gateway, and DNS server. Question: which of the following statements must be true? Answer: a host must have a unique IP address. Question: what specifies the router for a client to communicate with remote networks? Answer: default gateway. Question: how many octets does an IP version 4 address have? Answer: 4. Question: what specifies which address bits are network bits and which bits are host bits? Answer: subnet mask. Question: what is the loopback address for IP version 4? Answer: 127.0.0.1. Question: a user reports that he cannot connect to any websites. You run the ipconfig command and you see the following: IP version 4 address 169.254.254.43 and the subnet mask at 255.255.0.0. What is the problem? Answer: not connecting to a DHCP server. Question: which of the following is not a private address? Answer: 172.54.3.4. Question: what is the default subnet mask for a Class B network? Answer: 255.255.0.0. Question: what is the CIDR notation if you have a subnet mask of 255.255.240.0? Answer /20. Question. Which class would the following address be? 181.152.24.243. Answer Class B. Question. Which of the following is not a private address? Answer 200.24.43.3. Question. What is the network address of 153.34.40.101 with the subnet mask of 255.255.0.0? Answer 153.34.0.0. Question. What is the networking technique that allows network designers to divide an IP network into subnets with different subnet masks? Answer VLSM. Question. Define the binary number for the following. Answer Question. What is the CIDR equivalent to 255.255.255.224? Answer /27. Question. What is the CIDR equivalent to 255.255.224.0? Answer /19. Question. What is the CIDR equivalent to 255.255.248.0? Answer /21. Define the decimal numbers for the following shown on the screen. Answer shown on the screen. To help you with subnetting questions, particularly with subnet mask, it might be handy to memorize the 0, 128, 192, 224, 240, 248, 252, 254, and 255. After a while working with addressing and subnetting, these values will become second nature. For more information, visit these sites. In summary, a host is a computer or other network device that's connected to a TCP/IP network. For a host to communicate on a network, it typically needs the IP address, which is a unique logical address assigned to the host, a subnet mask that specifies which bits of the IP address is network bits and which bits are host bits, the default gateway, which is the IP address of the nearest router, which allows communications with other networks, and the DNS server, which will provide name resolution to IP address. The IPv4 address space consists of 32-bit addresses notated as 4 8-bit decimal values from 0 to 255, separated by periods. This is known as the dotted decimal notation, and the individual 8-bit decimal values are called octets or bytes. A subnet mask is another 32-bit value consisting of binary 1 bits and 0 bits. Subnet masks specify which bits are network bits and which bits are host bits. The IPv4 loopback address is 127.0.0.1. The 3 blocks of addresses allocated for private use are as follows: 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16. These addresses are not available on the internet. Dynamic Host Configuration Protocol, or DHCP, can automatically perform IP configuration, including IP address, subnet mask, gateway, and DNS server. Thank you for watching this video. The next video will be TCP/IP, Part 7, IPv4 Simple Subnetting. If you have not already, subscribe to the Pat Hatcherback channel. Thank you.